Good morning. Another YouTube. This time it's about Pythagoras. Sorry, it's a bit dark in here. It's the way the light is. Apologies. Pythagoras. A lot of students do find Pythagoras difficult. Just some things. This is a paper that Christian has given me this morning, so I'm going to mark that. There is a Pythagoras question there that we will do in a moment. If you do Year 11s, do papers, you can join our wine gum club, which is on a Wednesday. Do the papers. Come in, give me the papers, and you get a wine gum. But anyway, Pythagoras. Now, Pythagoras is all about right-angled triangles. So we've been looking to find a right-angled triangle this morning. We couldn't find one. So what we've done, we've taken a piece of paper, and we've cut it in half to make a right-angled triangle. So here is our right-angled triangle. So I could put that as a right-angled triangle, okay? So there it is. I think that camera comes a bit closer now, Mr. Luxton, that would be good. So we can look just a tad closer, the right-angled triangle. But, and now it's all about right-angled triangles, Pythagoras, right-angled triangles. So there's my right-angled triangle. And there is a formula called, it's called h squared equals a squared plus b squared. Now, in the true spirit of these YouTubes, trying to make it very simple. We're not trying to get it absolutely right. I'm not a maths teacher. We're trying to make it very, very simple so everyone can understand it. So this means that's hypotenuse squared. A hypotenuse is the name that we give to the side of a right angle triangle opposite to the right angle. It's called the hypotenuse. That's important, but more important to know do the question. And then for some reason the square of the hypotenuse out here equals the other two sides added up squared again. Okay, so it's easier for me just to show you a question, I think. So that's what I'm going to do. So on this question here, it says they sometimes do this. They give you a real sort of you know, well, it's a wall here, isn't it? Okay, it doesn't say that's a Pythagoras question. It doesn't say this is a Pythagoras question. Please do Pythagoras. It's towards the end of the paper, so it's question 25, foundation level, and it's 3 marks. Okay, so you have to just say, that's a right-angled triangle, and then want me to find that side of it. Okay, now I will find that side of the right-angled triangle in a moment, but I'm going to find the hypotenuse first, the longer side. That's actually asking you to find the other side, but I'm going to show you one of these first. So, if then we had, that was, let's say, 5 meters, okay, and this was 4 meters. Now, let's make that a bit easier for me. We'll make that 3 meters. So there we go, we've got a triangle, one side's 5, one side's 3, and it's asking us, okay, let's make it 4. Go back to make it 4. Make it 4 meters. That's asking me, what is x? What's hypotenuse? What's the longest side? How long is that side? So, I know the formula, h squared equals a squared plus b squared. So I'm going to put the numbers in now. So this side squared I need to find. So I'm going to call 5a, it doesn't matter whether that's a or b, it doesn't matter. So I'm going to say that's a, 5. So I'm going to say 5 and 4. So a squared, 5 squared, 5 times 5, a squared, 5 times 5. So I know that is 25, 5 times 5. Plus b squared, 4 squared, that is going to be, 4 squared is 16, 16, okay? So 16, okay? So add those two up, and 25 plus 16. 25 plus 16. So it's 35 is 10 plus 9 to give me 44. Is that right? 44. Is that right, Mr. Luxton? 44? 44. No, that's not right. I'm checking that again. That's not right. 40, 20, 41. 41. So I'll check that one. Check it, always make sure. So 25 and 16, 41. Now, that is not 41. H squared is 41. So I now need to get my calculator out possibly on this to find this thing here. The square root of 41 will give me that length there. The square root of 41 will give me that length. So I will go to my calculator and go bing, 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 bing on the calculator, square root of that, and I'm now know that is 6.403. 6, somebody give us a lesson? 6.403. So that is 6.403. So to one decimal place, that length, 6.4. Magic, magic, magic. If I had made that 3, not 4, as I was going to do in the first place, until my mathematical genius here told me to put 4, if I made it 3, it would have been 25 plus 9, 25 plus 9, 25 plus 9. Again, I'm thinking 25 plus 9 is going to be 34. Yep, 34. And again, I would just need to know the square root of 34, which Mr. Luxton is going to tell me in a minute from his calculator here. Just up to come up to 6 minutes. And the square root of 34 is 5.8. So we're in 5.8. 5.8. Now that is a simple Pythagoras. Now what your maths teachers will tell you is another little thing you need to be thinking of, that if they want to find that side, okay, that side, maths teachers would also explain how you find that side. And basically what you've got to do is you have to rearrange this equation here in the way that not looking for, you've got that one, you need to find one of these. So Mr. Wood and people will tell you, you take away something to get the other side. So there's Pythagoras. Hope that's helped. Please have a go at a paper. Have a go at that particular question. Plenty of past papers in here. That is Wednesday, the 12th of November 2008. Have a go at that one. Pythagoras. End of paper. See if you can do that. Bring it into me. Christian seems to think it's 1.7, so we'll have a look at that for him. Don't think might not have got that right, and he needs to put his workings in as well, okay? But we'll have a look at that for him this week. Okay, Pythagoras, more YouTubes next week.